Okay, so this is the moisture monitor schematic. This will look a little familiar. I've got a STM332U temperature sensor, and I modified it again with a resistor divider for the set point. I put a 10K resistor between ADIO 0 and ground, and then I put a pair of, you can see it here, a pair of galvanized nails as my variable resistor that'll go into the soil. And so that instead of the NTC thermistor, this will be my soil resistance will be the variable resistor. Okay, so I modified the STM332U temperature sensor in a similar way as before. So I put a series 1206 resistor between ground and ADIO0. At ADIO0, I brought a wire out to one of these female wire connectors. And then on the switch power port, I brought another wire out and brought it to another one of these female wire connectors so I could connect in my soil soil sensor variable resistor. Formed a resistor divider. I made all the mods so that it was easy to put the humidity sensor on, and the humidity sensor just plugs on. Okay, so the humidity sensor is now plugged in and it works very well. What I can do is I can show the sensitivity of the set point, and what I'll do is right now it's open circuit, so there's no connection, and what I'll do is I'll put a 10K resistor in series, as my sense resistor. I've configured it to sample every 10 seconds, so if everything goes well, I should see an update. And it should go to something like half scale. And here we go. We got something like half scale. Now, this would be semi-moist soil, I would imagine. And then if we have just really moist soil, we'd expect we're back to 0. We'd expect a short of some kind with a lot of moisture, and we would expect to go to full scale. And there we go, full scale. So now we know that our little sensor is reading at least 3 points okay. Okay, so I built a housing that would allow me to do a soil resistive measurement as well as a humidity measurement of the soil. So maybe I could do some correlation between resistivity and humidity. Wasn't really sure if the humidity measurement would be adequate, so I added the resistivity measurements, which comes in on these two wires. I'll get to that into a moment. So you have a plastic box and has a nice little cover that seals so that to keep the humidity only as determined by what comes in through this port. Because I could only find sort of small flexible tubing for this size box, I needed something to act as a support for it, so I got some threaded rod, 1/4-inch threaded rod, and use that as my support, and also it allows me to force the end of the probe into the soil at the same time. So I threaded this wire through the tubing as well. So the tubing exits with a kind of an angled thing to make it so it can push into the soil more easily. And then what I did was I took some galvanized nails and I made a soil resistance probe, and so they're separated by this small plastic tubing so that I can put it in the soil and I can get a resistance measurement based on the moisture. Here it gets transmitted. This DC value goes up to the temperature sensor. Okay, so we we placed the temperature sensor module in the box. We connected it up to the sensor probe cables. I have 1 k ohm resistors in series with each line to protect the temperature sensor from ESD and surges. Cover goes on that keeps the moisture coming in through the pipe here. And then at this end, you can see from our sensor that we're still open circuit. If I touch my resistor across the leads here, a change, and so that's kind of like mid-scale. And then if we go ahead and short it out, then we should get full scale. So this would be the soil is all wet and totally moist. Okay, so we have a bag of soil here. This will be a first test of the soil monitor. We're going to just plunge it in the bag here and see what we measure. And wow, that's pretty amazing. It's measures somewhere in the mid-scale, so that's about somewhere in the 10K, someplace greater than 10K. I'm really surprised. That's rather more moist than I would expect. All right, we're going to take the plunge. We're going to grab some soil here, and you can see from its consistency, there's doesn't actually feel wet. It's let's see if it clumps. It clumps a little bit, so you can see that we have a actual variable resistor there. Okay.